Welcome to solverfy.
We're asked to show that if m and n are even positive integers, the crossing number of kmn is less than or equal to m times n minus 2 times n minus 2 over 16. So let m and n be even positive integers. Now, as the hint suggests, let's place m vertices on the x-axis such that the vertices are equally spaced and symmetric about the origin. And this is possible because m is an even positive number. So we can put half the vertices on one side of the origin and half on the other. And then let's place the n vertices along the y-axis such that these vertices are also equally spaced and symmetric about the origin. So we'll do the same for n vertices on the y-axis. Again, since n is even and positive, this is possible. And now connect every vertex on the x-axis with every vertex on the y-axis. Now the number of points, the points are equally spaced and symmetric about the origin, so it follows that the number of crossings in one quadrant is 4 times the total number of crossings. So number of crossings is equal to 4 times the number of crossings in a quadrant. Now we know there are m over 2 vertices to the right of the origin and n over 2 vertices above the origin. There will be exactly one crossing per pair of vertices on the x-axis and per pair of vertices on the y-axis. Now the order of the vertices is not important, so it follows that there are C of m over 2 ways to select a pair of vertices on the x-axis. And again, since the order is not important, there are C of n over 2 ways to select a pair of vertices on the y-axis. And so in total, there are Cm over 2 times Cn over 2 ways to select a pair of vertices on the x-axis and a pair of vertices on the y-axis, since these are independent. And so we have the total number of crossings from before is going to be 4 times C of m over 2 times C of n over 2. This is equal to 4 times m over 2 factorial over 2 factorial times m over 2 minus 2 factorial times n over 2 factorial over 2 factorial times n over 2 minus 2 factorial. And this can be rewritten as 4 times m over 2 times m over 2 minus 1 over 2 times n over 2 times n over 2 minus 1 divided by 2. And so this reduces to m times n times m over 2 minus 1 times n over 2 minus 1. This is over 2. So m over 2 minus 1 is the same as 2m minus 2, or sorry, m minus 2 over 2. And so this becomes m minus 2, and then times n minus 2, all over. The 4 cancels out with the 2 2's in the denominators, and then we have 4 more 2's, so over 16. And so there is a way to draw KMN with m times n times m minus 2 times n minus 2 over 16 crossings. So the crossing number of KMN is going to be less than or equal to m times n times m minus 2 times n minus 2 over 16.